Ever wondered what happens when you shrink down to the size of an atom? In the quantum world, particles can be in two places at once, teleport through walls, and even talk to each other across the galaxy. It's like a video game where the glitches are real, and they power everything from your phone to the stars. Today, we're blasting off on a quantum adventure to explore this tiny, wild universe. If you're ready to see the impossible become possible, hit subscribe and let's dive in. Let's kick things off with the basics. What is quantum mechanics? In simple terms, it's a branch of physics that figures out how stuff behaves when it's super, super small, like atoms, electrons, and other tiny building blocks of the universe. These are the bits that make up everything, from your phone to the sun. The word quantum means energy comes in little packets, not a smooth flow. Imagine pouring sugar. It's not a steady stream, but tiny grains. Energy works the same way at this scale. It's chunked into bits called quanta. Cool, huh? Quantum mechanics started about 100 years ago when scientists like Max Planck and Albert Einstein noticed that the old-school physics rules, like how apples fall from trees, didn't work for these tiny things. They needed a new playbook, and that's what quantum mechanics became. It's now one of the most successful ideas in science, predicting things with crazy accuracy. Why does it matter? Well, it explains how atoms stick together, how lasers zap, and how your computer chips crunch numbers. It's the secret sauce behind modern life. But here's the fun part. The quantum world is weird, like really weird. And that's what we're going to explore next. Okay, let's zoom into the quantum world. How small are we talking? An atom is about 0.1 nanometers wide. That's a billionth of a meter. Compare that to a human hair, which is about 100,000 nanometers thick. We're in the land of the insanely tiny. At this scale, stuff doesn't act like the things we see every day. Take a baseball. You can throw it and predict exactly where it'll land. But in the quantum world, particles like electrons don't follow a set path. They're more like a game of chance. We can only guess where they might pop up. And get this, these tiny particles can act like waves too. Imagine if you could walk through two doors at once and bump into yourself on the other side. That's the kind of oddball behavior we see down here. It's because the quantum world runs on probabilities, not certainties. This shift from the predictable big world to the fuzzy small world is what makes quantum mechanics so different. It's like the universe flips the script when you shrink down, and we're just starting to peek at the madness. Now, here's a wild one: wave-particle duality. This says that tiny things like electrons can act like both particles and waves, depending on how you catch them in the act. Normally, we think of particles as little dots, like marbles, solid with a clear spot they're at. Waves, though, they're spread out, like ripples on water, and can mix together. But in quantum mechanics, particles can do both. There's a famous test called the double slit experiment. Picture firing electrons at a wall with two slits. If they're just particles, you'd see two lines on the screen behind, like bullet holes. But nope, they make a wavy pattern, as if each electron goes through both slits and messes with itself. It's like they're showing off their wave side. This flips everything we know upside down. Particles can stretch out and wiggle until we try to pin them down, then they snap back to being dots. It's a cosmic game of which one am I today, and it's totally real. Next up, Heisenberg's uncertainty principle. This one's a doozy. It says we can't know everything about a particle at once. Specifically, the more we nail down where it is, the less we know about how fast it's moving, and the other way around. It's not because our gadgets stink. It's a rule baked into the universe. Imagine snapping a photo of a racing bike. A quick shot freezes it in place, but you can't tell its speed. A blurry shot shows motion, but not its exact spot. Quantum mechanics says this trade-off is permanent for tiny stuff. So, particles like electrons are always a bit fuzzy. They don't have a set position and speed at the same time. They're more like a cloud of maybe. This fuzziness shapes how the quantum world works, making it a place where certainty just isn't a thing. Let's talk quantum superposition. This is the idea that something can be in multiple states at once, until you check it out. Ever heard of Schrödinger's cat? Picture a cat in a box with a random poison trap tied to a quantum event. Until you open the box, the cat's both alive and dead at the same time. It's in superposition. Don't worry, no real cats are harmed. It's just a thought experiment. In the quantum world, this happens for real. An electron can spin up and down at once until we measure it, then it picks a side. It's like flipping a coin that's heads and tails until you look. This trick is huge for quantum computers, which use superposition to juggle tons of options at once. It's a superpower of being everywhere until someone calls your name. Now, get ready for quantum entanglement, the spookiest trick in the book. When two particles get entangled, they're linked up, no matter how far apart they end up. Check one, and you instantly know about the other, even if it's across the galaxy. Einstein called it spooky action at a distance, because it feels like they're chatting faster than light. But don't get too excited. We can't use it to text aliens. It's just an instant connection. Think of two dice that always roll opposites. One hits a 2, the other a 5, every time, anywhere. Scientists have tested this, and it's real. It's used in stuff like super secure codes and even teleporting quantum info. The universe has some wild ways of staying connected. Here's another gem: quantum tunneling. This is when a particle sneaks through a barrier it shouldn't be able to cross. Imagine kicking a ball at a brick wall. Normally it bounces back, right? But in the quantum world, if you're tiny enough, you might just pop through to the other side. It's like a glitch in a video game. Why? Particles have wave-like vibes, and those waves can leak past obstacles. So, there's a chance the particle shows up where it shouldn't. This isn't just neat, it powers the sun's fusion, lets microscopes see atoms, and keeps some gadgets ticking. It's the ultimate cheat code. Last stop. How does quantum mechanics touch our lives? It's not just brain candy, it's behind tons of cool stuff. Take lasers. They use quantum rules to make focused light for things like cutting metal or playing DVDs. Transistors in your phone and computer? Quantum effects make them switch on and off. MRI machines scan your insides using quantum tricks with atoms. Then there's quantum cryptography for hacker-proof messages, and quantum computers, which could one day crack problems like designing new medicines super fast. All this comes from those weird rules we've explored. So, the quantum world might be small and strange, but its impact? Massive. It's like a hidden superpower driving our tech age. Whoa, quantum explorers. We just saw some seriously weird stuff. Particles acting like waves, teleporting through barriers, and entanglement that's like cosmic texting. And guess what? This isn't just sci-fi, it's the secret behind your gadgets and the sun's glow. If your brain's buzzing, hit that like button and drop a comment. What's the craziest quantum trick you learned today? Oh, and subscribe for more mind-bending quests. Next time, we're going even deeper into the quantum jungle. Stay curious, and I'll see you soon.